Hi, this is Pat Schuff with Making the Space. Today we're going to be looking at creating a flat pack stool using a CNC machine in the woodworking shop at TXRX. The original design comes from some plans that I downloaded from the internet, and we're going to see A, how well it works, and B, if we can recreate it from scratch. Welcome to Making the Space. Typically when I start a new design, I go online and look for a keyword like flat pack stool or a plant stand or something like that that allows me to look at different designs. And that's exactly what I did with this project. Squarish designs don't really appeal to me. I wanted something that was more circular. So the first one I looked at was nice, but it was too square for me and a little bit too heavy. So I moved on to something else. So the key phrase circular flat pack stool design tended to hit a wide variety of images. This is an example of a tall one and a short one, and the only difference is the height of the legs. The circumference is about the same, the inserts are about the same, and the cutouts are about the same, just slightly different, that scaled a little bit. I like this design, so I went out to see if I could buy one. And to be honest, for a straight woodworking project, I also found some pretty neat glass top tables that were just part of the research. I'm not doing this project, but I'm saving the image just in case I might want to do it in the future, either with acrylic or a glass top. One thing that did kind of appeal to me was putting a flat image on top. I like these Van Gogh portraits that you put on top of the flat pack design. I'm not necessarily going to do something like this, but it did make me think, could I put like a 6-pack of beer container and have a beer logo sitting on top? How would I do that? Would I do it in acrylic? Would I do it just with some varnish on top? So I played around with that a little bit as well. So fortunately, I didn't need to reinvent the wheel. I could go out and download a design, pay $1.50, I think is what I paid for it. And it basically is a CNC layout that I can put into Fusion 360, ingest the STL design, and then give it a depth of 3/4 inch plywood and tell it to cut. And that was the first thing I did. The basic dimensions of the design is it's a 16-inch circle, 16 inches high. It fits together very nicely, and I decided let's just buy it and cut it and see what happens. So the first phase of what I did was take a simple piece of 3/4 inch MDF and see if I could cut out the top circle and see how well it cut, if the bit I had worked, if the speed of the RPM worked, just the basic test philosophy of getting this STL file to cut properly. And then once I got it to cut properly on MDF, I took a scrap piece of plywood and did the exact same thing. Fortunately, the 18,000 RPM spindle speed worked perfectly fine, as well as the sheet feed rate of 60 centimeters per second and 40 centimeters per second for the plunge rate. Worked perfectly fine. Everything cut out just the way I expected it to. I was using a spiral up bit for this test just to see what would happen, and later I tried a spiral down bit just to see if that made any difference. When I cut the leg, it worked fairly well. There were a couple minor issues on this image. On the top left, there's a little tab there that shouldn't be there. And then just slightly above the right, I had to just get an X-Acto knife and cut that out. For the most part, it worked out well. Things cut the way I expected it to. It came off the CNC machine without any problems. I had the depth right, I had the tabs right. Everything worked as expected. What didn't work as expected was the spiral up bit tended to chew the plywood. It shredded it as opposed to cutting it. I don't know if a higher speed would solve this. I tried a downcut bit later and it cleaned it up much better. So I think with plywood using an upcut bit, it causes too much tear out. So it doesn't work on all areas, but on flat areas that are parallel to motion, in parallel to the grain, it tends to rip up the grain. So I don't think I'll be using an up spiral bit for plywood in the future. With the initial design, it did have some problems. The tabs for the legs were a little bit too wide and too thick to go into the holes for the top. And that has to do with no tolerance for a little slop, a little gap. I put in a 3/4 inch width slot in the top, and it really needed 3/4 inch plus a 1/16 plus 2/16 so it would slot in. And then I did an 1.5 inch length for the mortise and an 1.5 inch for the tenon. Well, given that the tenons are cut as circles along the edges as opposed to hard squares, the hard square edge on the legs didn't quite fit into the top. So I had to get a hammer and chisel it out and try to smooth things out a little bit, and it worked perfectly fine, but it did require a lot of post-processing. So fortunately with the post-processing, everything fit together. The mortise slid into the tenons. Everything lined up the way it was supposed to. The thickness was right. The width of the tabs were right. Everything slotted in as expected, and the stool was a little fine. Had a tiny bit of wobble, but that could be easily fixed with a rasp to level it out just a little bit. So overall, not bad for a first pass. So with the design done and everything fit together and worked perfectly, I thought I'd go back and try a second tweak to reduce the amount of time needed to fit everything together. So I went with a slightly different pattern, had more of a hexagon just to see how sharp an edge the 1/4 inch CNC router bit would cut, and then added tolerances. So added a little bit of tolerance on every joint where a mortise fit into a tenon. So I made the mortise a little bit wider, made the tenon a little bit shorter so that everything would fit appropriately, and tried to make the depths that things would fit in as precise as possible. So the beautiful thing about Fusion 360 is I can go in and tell it to add some tolerance. And the tolerance can be added to the width of a mortise, to the subtracted from the width of a tenon, so that everything fits just appropriately. And if I'm off a little bit, I can make it 2/16 as opposed to 1/16, or something different if I needed to. To double check and verify this, we looked at the width of the tab that goes into the top, and it's 2.5 inches. And then we look at the width of the mortise on the top to see that it's 2.5 inches plus a couple 16ths, which is exactly what we wanted. We wanted it to slide out a little bit so that the rounded edges don't trap the square edges from the legs, and things will work perfectly. As I do with any CNC project, I first go in and simulate it by defining all of the internal cuts, all of the external cuts, and then telling it to perform an action of simulate so I can see how it's going to cut, if it's going to cut deep enough, it's going to cut the right location, and verify before actually putting spindle to wood. So the CNC machine at TXRX is a Linux CNC, and you basically generate the NGC code from Fusion 360, put in the spindle, get everything lined up, set the XYZ direction, and then tell it to go. This is an example of lining everything up. The design is a top to bottom design as opposed to a left and right design. But when I bring it up in Linux CNC, I can see it, orient the wood appropriately, screw it down, and tell it to go, and it will cut everything out as I expected. Before we unscrew anything, we want to go through and use the air compressor to blow out all of the sawdust, make sure the tabs are there so that we can get a hammer and chisel and chisel out the tabs that are holding the piece in place. And then look at making it clean, making it a smooth edge, and pulling it off the table. And then once we pull it off the table, we can unscrew the wasteboard and throw it away. In the design, I put a tab every 3 inches so that it will hold it down. We could put it every 5 inches and it'd be perfectly fine. So given that this is a 16-inch run, the edge tabs on the height would work perfectly fine. I was a little worried about the circle, so I put a tab every 3 inches. We can go in and punch it using the hammer and chisel that's over by the band saws and the sanders, and it pops out very nicely. The tabs might be a little hard to see here. There are a couple of dark spots in there that are at the very bottom of the leg, and then there are others in other areas. They're not stacked on each other. They're typically opposite each other on the design. They're simple with a chisel just to pop out and then sand off. The other thing I wanted to look at in this design was if I tried to create a honeycomb pattern, how sharp an edge would a 1/4 inch get. And as expected, it's not a sharp, crisp edge. I could go through with a chisel and square it off, but the 1/4 inch bit does create a bit of a round over. It's not exactly a circle. You can tell it's a hexagon. It's just not a perfectly square hexagon. It's a rounded hexagon, which is not a bad design element. I could fill this with some acrylic and use some yellow acrylic to make it look like a honeycomb with honey in the middle. The final thing to note, and this is more with the CNC machine, it did cut a little bit into the wasteboard, maybe a 1/16 of an inch, but you can see the shaded outline of the legs once I take everything off, which says the Z was just a tiny bit low, and that's exactly what I was hoping to do, because it's okay to cut a little bit into the wasteboard. We just don't want to trash it completely. Prior to sanding, we go over to the glue up table and dry fit everything. The fit looked good. It was a little rough, just a tiny bit wobbly, but I could sand that down. I could use a sanding block or a rasp just to get the 1/16 that caused the wobble, and everything worked perfect. Next step is to figure out how to finish it. The final design for this is going to be used as a plant stand outside. So I put some white paint on it. I'm going to paint the edges a different color to match the rest of the lawn furniture, and then polyurethane on top of it to make sure it sticks. Now, I will not glue together all the parts. I'll leave it so I can disassemble it, since these fit into each other. I don't need to make it permanent. I can repurpose it to something different at a later time. What you're looking at is a first pass at the paint. It's not the smoothest. I have to sand it, repaint it, sand it again, and then paint it and polyurethane it. Overall, I'm pretty happy with this project. It's easy to cut out. It takes maybe 30 minutes. Getting all the lumber into the wood shop, getting the CNC machine set up, having it cut it, doing just a little bit of post-work sanding with the down spiral bit. I didn't have the tear out that I did with the up spiral bit. These will be nice additions to the back patio with plants on top. Relatively simple to do. I used scrap material. A 1/4 sheet of plywood would probably make one of these, just because it's 16 inches in size. You could make them smaller, you could make it larger. You could do 2 of these on a 1/4 sheet of plywood, or 1 of them on a 1/2 sheet of plywood. It just depends on how big you want to make it. And all of that set in the Fusion 360 on how the radius and the height, those are just variables you go change and make it as big or as small as you want.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.